Absolute value is an idea in math that can be very simple, but sometimes can be very complicated. The simple way to think about absolute value is simply the distance away from zero that a number is, or a expression. For example, the number 3 has an absolute value of 3. Now, absolute value is indicated by a set of parallel lines. So this notation means absolute value of 3. And its value is equal to 3 because 3 is 3 numbers or 3 units away from 0. However, the absolute value of negative 3 is also equal to 3 because negative 3 is also 3 units away from 0. So this is where it can be confusing. It's just like anything in math, it can be one thing or the other. It's easy to get things backwards. Now, absolute value gets a little more interesting when we start dealing with expressions. For example, let's take x minus 3, absolute value of, equals 5. Well, we've seen that if what's inside the absolute value bars is either equal to 5 or negative 5, then the absolute value of it will be equal to positive 5. So when you solve something like this, you need to split it into two pieces. Either x minus 3 is equal to 5, or x minus 3 is equal to negative 5. So by solving these equations, I'm going to add 3 to both sides, so I get x equals 8. And here I'm going to add 3 to both sides, so I get x equals negative 2. So if x is either 8 or negative 2, then the expression absolute value of x minus 3 is going to be equal to 5. Because putting those values in gives me either a value of 5, which the absolute value of is positive 5, or this one, negative 5, whose absolute value is also equal to 5, the distance away from 0. All right, let's look at a couple examples here. So let's say we're asked to solve this equation. Absolute value of x plus 6 is equal to 4. So first thing we have to do is split it into those two different pieces. Either x plus 6 is equal to 4, or x plus 6 is equal to negative 4. So solving both of these, I'm going to subtract 6 from both sides. So x equals negative 2. Subtract 6 from both sides. X equals negative 10. So this equation has two solutions. Either x is equal to negative 2, or it's equal to negative 10. All right, let's try another one. Absolute value of 2x plus 1 equals 5. So once again, what's in here in the absolute value bars is either going to be equal to 5 or negative 5. So we set up our two equations. 2x plus 1 equals 5. 2x plus 1 equals negative 5. Solving both of these, we're going to subtract 1 from both sides. Get 2x equals 4. Divide both sides by 2. Get x equals 2. Over here, subtracting 1 from both sides, we get 2x equals negative 6. So x equals negative 3 when we divide both sides by 2. So for this particular absolute value equation, either x is equal to 2 or x is equal to negative 3. All right, again, let's try another one. Let's say absolute value of 3x plus 5 equals negative 2. Now, hopefully, someone has realized that an absolute value equation can't be equal to negative 2. So this is something you have to kind of watch out for. Remember that whatever is in here, we're talking about the distance away from 0. So on our number line, if this is 0 anything that's here has some distance except for 0 itself. So the smallest value we can possibly get for something that's absolute value is 0, because 0 is 0 away from itself. So in an equation like this, there is no solution. We could also say just D&E does not exist. All right, let's try one more. Absolute value of 2x minus 7 equals 0. So in this case, what's in here can only be 0. That's the only possibility. So if 2x minus 7 is equal to 0, that's the only thing we can have. So we'd add 7 to both sides, get 2x equals 7, divide both sides by 2, and get x equals 7 halves. So if an absolute value expression is equal to 0, we can only have one solution. All right, here's a slightly more complicated equation where I have an absolute value expression equal to a regular non-absolute value algebraic expression. But the same procedure holds true as before. Either x plus 6 has to be equal to 3x minus 2, the positive, or x plus 6 has to be equal to the opposite of 3x minus 2. Now notice I use parentheses because I want the opposite of all of this, not just the opposite of part of it. So the parentheses are important. All right, so now we can solve both of these. I could add 2 to both sides. Then I could subtract 8 from both sides. Subtract x from both sides. And divide both sides by 2. So there's my one solution. Now remember that a negative in front of parentheses like this is like distributing a negative 1. So I'm going to distribute that out, and I get negative 3x plus 2, because I have my negative times negative. So now I go ahead and solve again. So I could subtract 6 from both sides. And then I could add 3x to both sides. And finally divide by 4. So my solutions are either x equals 4 or x equals negative 1. Now we have to be careful that we always, as usual, check our answers. So let's put in a 4. It would be absolute value of 4 plus 6 equals 3 times 4 minus 2. Well, this is absolute value of 10, which is 10. And this is 12 minus 2, which is 10. So that answer checks out. Let's try this one. Would have absolute value of negative 1 plus 6 equals 3 times negative 1 minus 2. Well, negative 1 plus 6 is 5, so absolute value is 5. And 3 times negative 1 is negative 3, minus 2 is negative 5. So these two don't match. So in this case, we only have one solution when x equals 4. This one is a false solution. So you always want to check to make sure in these kind of problems that both solutions are actually true.